So applications of acceleration. To solve a problem, remember DFIC. This is not the end-all, be-all. This is just to give you an approach page. Remember DFIC, I said, you don't need to write this down if you don't want to. List your data, find a formula, insert the numbers, and calculate the answers. This is actually a terrible way to solve things. You'll get better and you'll just become intuitive. But if you're looking for a starting point, Gabor, this is where I would go with. Says this, an object starts at rest. You know what? I would underline the phrase at rest. What does that tell me? What's 0? VI is 0. I'll remember. Or if you want to be lazy but organized, you could write above there in really small writing, hey, VI is 0. Or if you can remember that till we list our actual data, I'm fine with that as well. And travels 12 meters over the next 3 seconds while accelerating constantly. Find. Okay. Ileana, what does A want me to find? What does part A want me to find? Yeah, and I think it's fairly obvious. This is why I said physics in many ways, although it's all word problems, they're way easier than the ones you do in math because you can figure out what they're asking for. So what are they asking me to find? Say it again, you're right. I'm going to go A equals question mark. Paige, have I written something down? Do I feel better? Am I more relaxed? Are my odds of success going to be? Yes. You're hopefully cluing in. That's a big part of my problem-solving strategy. I try and write down. I can't call it a no-brainer. You need to know a little bit, but I try and write down something obvious. Now, Eliana, we're going to go back through the question looking for physics words and numbers. At rest. What did that tell me? Let's write that down. 12. What's that? What are the units next to that 12? So is it time? It's got to be distance. This is why it's worth memorizing what units go with what. Meters is distance. It's probably a displacement, but we're not going to be that fussy this year. So I'm just going to go D equals 12. I see a 3. See it? What are the units next to that 3? So it's got to be. That's the D part of the DFIC. That's listing my data. And you'll notice I know 3 things. What you're going to find is you need 3 things to find the 4th one. And then once you found the 4th one, you can also find the 5th one. So there's really 5 variables, VI, VF, A, T, and D. Any 3 gets you all 5. Now I'm looking for the equation. Eliana, on my green sheet, there's an equation that has an A, a VI, a D, and a T. Which one? D equals VIT plus a half AT squared. Everybody see it? Technically, Eliana wasted my time. Eliana, what's VI? What's 0 times 5? What's 0 times 10? What's 0 times T? So if you had really wanted to impress me, you could have read the special modified version when you start at rest. You could have said, actually, Mr. Dewick, it's just AT squared over 2. Or 0.5 AT squared. I don't care which version you prefer. I won't take marks off if you don't catch that, but for what it's worth, yay! What are you trying to get by itself? What are you trying to find? A. Do you want to use the left-hand equation or the right-hand equation? Pick. The right one with the decimals in it? Fine. How will I get the A by itself? The 0.5 is adding the A? So what are we going to divide by? A 0.5 and a t squared. Yeah. You see it? We're going to get this, yet another equation. Don't memorize it. Apparently, acceleration is d divided by 0.5 t squared. Or, if you use the first equation, acceleration is 2 times d divided by t squared. Those are identical. But you like the other one. Okay. What was D? 0.5. What was T? Is this a fraction? Is there more than one thing on the top? I don't need brackets around the top. Is there more than one thing on the bottom? Everybody try typing this in, please. I'm going to try doing this in my head. I think I can. It's going to be 24 over 9, so it's going to be 8 over 3, so it's going to be... is it 2.6 repeating? Double check me. Is it 2.6666666? Now, you need to try that and see if you get that. Every year, I have some kid who has all the right writing on their calculator and the wrong answer, and I know it's because they were too lazy, or I don't use this word very often, too dumb, to bother typing these in during the lesson and see how their calculator works. Well, I got no use for that. I'll go 2.67, 3 sig figs. Units, it's an acceleration. Meters per second squared. Mr. Dewick, what if I blank on the units? Go look at another question, and I'll bet you'll see the correct units next to something that you know is an acceleration, and you'll get it. Just like on a French test, you've all clued in, if you forget a word in the vocabulary, you might find it somewhere else in the test. Like, I hope you picked up on that little trick. So I just blew some of your minds. Wow. Need to teach you all how to write tests better. Cool. Nicole, what does B want me to find? What is that as a symbol? Yep. Has anything changed? No. I'm not going to relist everything. I'm looking for an equation that's got a VF, a VI, a D, and a T in it. Now, I do know A. Everybody look up. The easiest one would be this one. Don't write this down. And the reason that would be the easiest is it already has the VF by itself. If I'm a good test writer, why might I avoid using this one? Why would I avoid using this to find that? Yeah. No. Even more obvious. Yeah. No. Even more obvious. Yeah. If I got that wrong, I'm getting this wrong. Right? So, find me an equation that's got a VF and those three. There is one. Nicole, which one? I disagree because you said A, and I don't want to use A. Try again. Yeah. The one with brackets, yes? Yeah, that one. D equals bracket, VI plus VF, close bracket, over 2 times T. Yes? All right. Now, Nicole, VI is 0, which means technically it would vanish, giving us an easier equation. But because this is a really yucky one, I'll leave the VI as a VI just to show you how we would deal with it. So are you ready? What are we trying to find? What are we trying to get by itself? Where is the VF right now? Inside the, I'm looking for where that starts with letter B. I'm going to do that last because it's reverse bedmass. So move outside the brackets. What's the T doing to the bracket? So, what's the 2 doing to the bracket? So, my first step would be to do this. The D would drop down like a domino, except I've run out of room down, so the D is moving sideways like a domino. Anyways, the D would go to the next line. Times by the 2, divide by the T. And that would leave me with the bracket. There's nothing outside the brackets anymore, so the bracket is redundant. It just vanishes. How would I get the VF by itself? But if it wasn't for this yuckery equation, I totally agree with you. But if it wasn't, how would I get the VF by itself? Subtract what? Thank you. Look up. it would look like this. See how clever that was? I can do that with digital ink. So let's walk through it properly, because you guys can't do that, I realize. Okay, fine. So you would subtract the VI, you would get this. 2D over T minus VI, not inside the fraction, tacked on to the end. And Nicole, that would equal VF, but do you mind? I'm going to go VF equals on this side, because that's where we're used to seeing the thing by itself. That's a fairly tricky one. That's one kids really struggle with, but it's doable. Now I agree with you, Nicole. VI is 0, so everybody, if you want to now, you can cross that out. To Nicole, what was D? What was T? 8. Yes, people? Double check me. Yeah? And I'll make it look really impressive. I'll go 8.0. Units, you can even go 8.00 to 3 sig figs if you wanted to. Units, meters per second. Okay? So we can find a velocity anytime we want to, given enough information. We can find an acceleration, given enough information. Let's go swimming with dolphins. A dolphin accelerates from 1 meters per second to 7.6 meters per second in 5 seconds. Ooh, cool. Tyson, what does part A want me to find? Find the... I totally agree with you, Tyson, my friend. Let's put a little letter A. Let's write down A equals question mark. Hey, everyone, what's that 1.0? First of all, what are the units next to that 1.0? So that's a time, right? Oh, no, what is it? It's a velocity. Here's the question. Initial or final? This part I can't really help you with, Tyson. All I can say is read the time flow of the question and figure out, is this how fast we started or is this how fast we ended? Tyson, that one, VI or VF? I totally agree with you. Let's write down VI equals 1. You get a little nerdy adrenaline rush? Look, you're doing physics. What's that 7.6? Again, it's a meters per second, so it's a velocity. Gotta be. What's that 5.5? Yep. Also, Tyson, any yucky units that you saw, like kilometers or hours or anything, I'm always double checking that there will be some a bit later where we have yucky units. We'll have to do a conversion. But for now, we're good. I'm looking for an equation, Tyson, that has an A, a VI, a VF, and a T in it. There's only one. I don't know. They're not in any order. Read it to me. Stop. Did you hear what he said? VF equals VI plus AT. Y'all heard it? Is it on your green sheet, Tyson? That I'm not going to write it out. Instead, look at it. I'm serious. Stare at it. What are we trying to get by itself? The A. See it? What side is the A on? Keep looking at it. What's going to drop down like a domino then? The VF, yes? Keep looking at it. What side is the A on? The right. What's right next to the A, Tyson? Yeah, I agree with that. What's the T doing to the A? How do we move it over? Remember that, remember that, remember that. What's the VI doing to the A? So, which one am I going to do for reverse BEDMAS? Right? Tell me what to write. VF, keep going. Now, this is the stage we'll get to. I'm pushing Tyson because I think he's pretty good at this. So, VF, you said subtract, so what am I going to subtract? Yep. Keep going. All over AT? What am I trying to get by itself? So don't move the A. Yes. Oh, I love the way, you went, T. Yeah, and now it's obvious. Yeah. Why would I move the A? That's what I'm trying to get by itself. The T. And then Tyson, look up. Technically that equals A, but do you mind? Can I go A equals over here? That's the stage we're going to try and get to by the end of this week. Can we look at an equation, not even write it down, because it's on your sheet. By the way, if you want to write it down because it makes you feel better, go ahead. I'm not taking marks off. But can I look at it on my sheet, see everything moving around, and rewrite it? What was VF as a number? Keep going, Tyson. Let's finish this off. What was VF as a number? Minus all over. Is this a fraction? Is there more than one thing on the top? Brackets around the top or your fancy schmancy fraction button? I don't think you need brackets around the bottom. I can do this in my head. It's going to be 6.6 divided by 5.5. It's going to be 1.2? Yeah?
Yeah.
I can do math in my head. You get that as well? I don't even think you grabbed your calculator, and I'm going to glare. Did you do it on your calculator? Follow along next time. Units, it's an acceleration. Yes. Mr. Dewick, how big is 1.2 meters per second squared? That's going to be Wednesday's lesson. We'll talk about how you can tell how big an acceleration is in terms of G's. This is doable. A little weird, but I'm telling you, if you get to this point, can you see how it really cuts down on your memorization by like a gabillion? Is a gabillion a number? It is now. Victor, what's B want me to find? Hey, D equals question mark. I'm looking for an equation, Victor, that has a D. I'd like it to have a VI, a VF, and a T. I'd like to avoid the A if I could. And there's a bracket there, I think, as well, somewhere, yeah? Yeah. I need to get the D by... Ha! Already is. What was VI? What was VF? Over 2. What was T? Okay. That T is on top of the fraction. So is this a fraction? Yeah. This one I'll type with you. You're either going to hit your fancy fraction button. So I have to have a bracket around the top, and then I have to open a second bracket because of that little small one. 1 plus 7.6. Mr. Dewick, why wouldn't I just go 8.6? Yes, if it's easy, Dean, you can add 1 in your head. But for complicated ones, we'll walk through how you would do it for stuff you can't do in your head. I would close off the small bracket. What's happening between the 5.5 and this bracket? Adding, subtracting, multiplying, or dividing? So I'll hit times 5.5. I've reached the end of the top, close off the top. Divided by Victor, is there more than one thing on the bottom? Don't need brackets around the bottom, just divide by 2. Did you get 23.65? We'll call it 23.7. Units, it's a distance. Yeah. By the way, let's suppose this was a test question and you finish early. There is another way I could have found the distance. It's this, VIT plus a half AT squared. I might quickly go on my calculator and just go VI1 times T, 5.5, plus 0.5 times A. My answer from part A times 5.5 squared. And if I get the same answer, which I did, hey, I know A was right as well. A good way to check your answers, you'll often find, especially if there's a part B and a part C, that you can find part B and part C in more than one way. If you get the same answers both ways, you got to be right. Or for that matter, up here, Nicole, I could have very quickly gone VF equals VI plus AT. I could have said it's going to be 0 plus 2.666. I've just typed a bunch of 6's in times 12. And if I also get the... did I type that wrong, Mr. Dewick? What was D? Oh, sorry, time was 3. Geez, Dewick, not 12. I got it mixed up with the distance. And if I also get 8 or really, really close to it, because I rounded off, I know I'm right. Okay? Example 3, let's do some traffic management. A car moving at 30 meters per second to the right slows down at 6.8 meters per second. Another word worth noticing, another phrase, is that one, slows down. What did that tell me? What about the acceleration? What? I'm going to go like this. So I don't forget. The acceleration is negative. Now, I might be nice and say slows down at negative 6.8 meters per second squared. I might give you the negative, but not always. A, how far does the car go before stopping? Cool. I can do this. Mariko, what's part A you want me to find? What is how far? Time? It's got to be distance. Probably a displacement technically. Okay. D equals question mark. Mariko, what's that 30? It's a velocity, initial or final? How did you figure that out? Well, it seems to, in the time flow of this question, seems to be how we started at. What's that negative 6.8? Uh-oh, that's only 2 things. I need 3 things to find the 4th. I guess I can't do this. Or can I? What else did they tell me? So now, of course, you're going to keep reading and look in part A. They told you something else. Before what? What's that tell me? First of all, that's probably a physics word I should have mentally underlined. Yep. I'm looking for an equation that's got a D, a VI, an A, and a VF in it. There is one, and only one. Equals VI squared plus 2. Everybody see it? It's the 4th one. They're not, by the way, they're not in any particular order, so don't go to university and just say that it's the 3rd equation, Mr. No, I just put them that way. What is it again? VF squared equals VI squared plus 280. Everybody look at it. Everybody on your green sheet. We're trying to get the D by itself. Mariko, what side is the D on? Stare at it. What's going to drop down? The left side, the VF squared. I would write that down, then I would go stare at it again. What's right next to the D? There's 2 things. What? How am I going to move the 2A over? Remember that. What else is on the same side as the D? How am I going to move the VI squared over? Talk to me. VF squared. Yep. All over. That equals D. Get a little nerdy adrenaline rush to you? Isn't that fun? Mummy, I'm doing, look what I learned how to do. This is why we don't want to write them all on our sheet. It's much better. By the way, VF is 0, but I tend not to cross it out just yet because it's going to be a little weird. So it's going to be 0 squared minus 30 squared all over 2 times negative 6.8. Is that a fraction? Is there more than one thing on the top? Yeah, brackets around the top. Is there more than one thing on the bottom? Brackets around the bottom, unless you have the nice fraction button.
Starting to see why you said get a good calculator, Mr. Dewick.
Do y'all get 66.1764 that? Did we get a positive answer or a negative answer? The car ended up in front of where it was going. But yeah, it's slowing down, but it hasn't gone in reverse. It came to a stop. That makes sense. If I got a negative answer, I would have, a little nervous. 3 sig figs, 66.2. Units. Yeah. Hannah, what's B want me to find? How long? Isn't how long distance? Oh, yeah. How long is a vague phrase in English? It can mean distance or time. How long was the movie? Time. How long is a football field? Distance. But since we just found distance, it's got to be time. So I'm going to write down T equals question mark. Hannah, we're looking for an equation that's got a T, a VI, and A, and a VF. We'll use a D if I have to, but I'll try and avoid that because I might have got that wrong. Which one? And this is what all of you want to play along at home with. This is what you want to try. This is the skill. Finding the equation is step one. Sorry? I disagree. I think there's one that has a T, a VI, a VF, and an A. Thank you, Mesa. But she wants to find them herself. You said VF equals VI plus AT? Yeah? Good. Get the T by itself. Yep. So here's what I'd like you to do. You ready? Read to me. T equals, what am I going to write? You said VF, then what? How would I get the T by itself? You just talk. Not yet. You said something else first. Minus VI. There. You see it? Yeah. Good. What was VF? 0. What was VI? 30. What was A? I was a little bit nervous because I thought, oh, when I went 0 minus 30, I'm going to get a negative answer. Time can never be negative. But then on the bottom, I've got a negative. What's a negative divided by a negative? Are you positive? What do you got? Is this a fraction? Brackets around the top? I don't think you need brackets around the bottom. Hannah, what'd you get? I know. That's my way of encouraging you to type. Is it 4.41 to 3 sig figs? Yeah? Is Hannah right? Yeah. So you got to press the S to D button. Give me a second here. Hang on. 4.41 units, Hannah. Time. Yep. Okay. Example 4. A car travels at 15 meters per second and speeds up uniformly. That's my way of saying we have a constant acceleration, so we can handle this in Physics 11. Over the next 5 seconds, it travels 85 meters. Mesa, what's example 4 want me to find? Good. What's that 15? How do you know it's VI and not VF? Because I think it's speeding up, which implies there's another velocity later. This is why you kind of follow the time flow. So I agree with you, Mesa. What's that 5? What's that 85? Sorry? I don't think, did you say VF? I disagree. What are the units next to that 85? And I love the way you did that. You looked at the units. Oh, yeah. And I would say that once we've memorized what units go with what, we'll call that a silly mistake. We won't do that, right? Which equation? She said D equals VIT plus a half AT squared. It's one of the tougher ones to work with, so this one I'll write down. Although eventually you'll get good enough that you won't even bother writing this one down, Mesa. What are you trying to get by itself? What's going to drop down like a domino? What's right next to the A? There's two things. Yeah, and instead of a half, I'm going to think 0.5 and the T squared. What are the 0.5 and the T squared doing to the A? How will I move them over? Remember that, remember that, remember that. What else is on the same side as the A? What's the VIT doing to the A? So tell me what to write. D minus VIT all over that equals acceleration. Don't memorize it. We'll learn how to derive it. Much better place to get to. If you try making lists of all of these, you'll do yourself a disservice. Okay. 85 minus 15 times 5 all over 0.5, 5 squared. Is this a fraction? Brackets around the top, brackets around the bottom. Actually, I think I did this in my head. 15 times 5, 75. 85 minus 75 is 10. 20. 20 over 20. Is it 0.8? Even? Yeah. I'll go 0.80 because I did it in my head and I want to show off. I went to like 2 sig figs. Is that right? Yeah? Mesa, units. Yeah. That's a pretty small acceleration. You could feel it, but it wouldn't interrupt your conversation or anything like that. In fact, probably you'd be able to still sip a cup of coffee under that acceleration without having to really adjust your coffee sipping technique. You've noticed sometimes when it sloshes, you have to be more careful, right? So where can we use this? We've looked at some car things, okay. Airport design would be a place we can use this. Here's an application. It says this: a jetliner needs a takeoff velocity of 288 kilometers per hour. 288 what? I'm doing a unit conversion. In order to safely leave the ground, if the jet's engines can accelerate the jet forward at 3.5 meters per second squared, what's the minimum length of the runway? Ooh. Okay. Gabor, what's this question asking me to find? Yeah, it said length, but I realized that's distance. What's that 3.5? What's that 288? Is that the initial velocity of the jet or the final velocity of the jet? I think that's the final. So let's write down VF equals 288, but now there's yucky units, so we'll write the units kilometers per hour. I can't remember, Kyle, if you were here or not. We added something to our green sheet. How do I go kilometers per hour to meters per second? Something with a 3.6? Is it divided by 3.6? $80? I made that one work out nice for you. So I got A, I got VF. I need 3 things to find the 4th. There must be something else. I don't see it in the question, though. Yeah. What was that? I think every airplane, when they take off, they come to a stop at the beginning of the runway. I think we can safely say VI equals 0. I've never seen a jet airliner go squealing around the corner and gun it, right? They have to wait for clearance. a reasonable assumption? Gabor, I'm looking for an equation that's got a d and a VF and a VI. There is one. VF squared equals VI squared plus 2AD. Y'all see it? Can you get the d by itself? I'll give you a hint. D equals. So first of all, what's going to drop down like a domino? Good. Keep going. Yep. Yep. Don't memorize it. Derive it. So it's going to be 80 squared minus 0 squared all over 2 times 3.5. You get 914? Units, Gabor? Oh, okay. Oh, I think brackets around the top and brackets around the bottom for this one, yes? Or fancy schmancy fraction button. You get that okay? Yeah, 914 units, meters. So you could use this in your runway design. Now let's be clear, you would never build the runway this short. You'd probably triple it for safety, because this would be, the jet starting with its back tires on the grass, and right when its front tires hit the far end, that's when it's lifting. Oh, that's cutting things way too close. But you can't build it any shorter than this. So you'd probably say, yeah, we'll build it 3 times as long to give ourselves a good safety margin. Okay, so there's one application. Example 6, playgrounds. Here's another application. A child slides down a playground slide, accelerating from rest. I probably underlined the phrase from rest. And traveling 6 meters in 4.8 seconds. When they hit the ground, their legs bend 20 centimeters. 20 what? Do I do physics with centimeters? I'll have to do a conversion. As the child stops. A, how fast does the child hit the ground? B, what is the child's acceleration in stopping? Okay. This is a much tougher question than the ones we've just been doing thus far. And it's a bit weird because, don't circle this, but that's 6. What is that? That 20, what's that? Also a distance. You see it? I think this question has 2 parts. Do you know how I know that this question has 2 parts? 2 distances. So there's my first inkling that this question is much tougher. And what are the 2 parts? I think on the slide and on the ground. Because this distance, they're on the slide, but this distance is when they hit the ground. So I told you I'm going to be lazy but organized. How many parts does this question have? Slide. Ground. And now I'm going to read through this very carefully, and I'm going to look for physics words, and numbers, but I'm also going to ask, are these on the slide or on the ground? So from rest, what's that tell me? VI is 0. Are we from rest on the slide or on the ground? Six. What's that? On the slide or on the ground? I think still on the slide. 4.8. What's that? On the slide or on the ground? When they hit the ground, ooh, now I'm on the ground. The legs bend 20 centimeters, so D is 20 centimeters. I need to convert that to meters. Does anybody know how many centimeters, sorry, how many meters 20 centimeters is? It's 0.2. It's divide by 100, or we can set up a full chain. But let's just make a little note, 0.2 meters. Stops, another physics word. What's that? Tell me. What's zero? VF. What does A want me to find? How fast does the child hit the... What's that? I think B wants me to find acceleration. I don't think how fast is acceleration. What is how fast a measure of? It's velocity. Initial or final? Maybe it depends where. What would my hitting the ground velocity be over here? Initial or final? You know what? I think part A, even though it says hit the ground, it wants me to find V final at the bottom of the slide because that's how fast I hit the ground at. Kayla, you okay with that argument? Kayla, I'm looking for an equation that's got a VI, a D, a T, and a VF in it. There is one. The one with brackets, right? Okay. That's a tricky one. Let's write it out. D equals bracket VI plus VF close bracket times T over 2. What are we trying to find? Where's the VF? Inside the... Do it last. How will I move the T over? Yes. Ready? Everybody look up. Lazy but organized. How will I move the T over? How will I move the 2 over? And I get this. 2 times D over T equals VI plus VF. What am I trying to find? I want to get the VF by itself. How will I move the VI over? Except what was VI as a number exactly? So you know what? On this line, I'm going to go because 0 plus doesn't change anything. Okay. I get VF equals 2 times 6 over 4.8. I can do that in my head. 12 over 4.8, that's going to be the same as 120 divided by 48, divided by 12, divided by 12 is going to be 10 over 4. 5 over 2. Is it 2.5? Yeah? Well done. Give yourself a little nerdy pat on the head. Cool. Maxine, what's B want me to find? Ooh. Where? Are we stopping on the slide or on the ground? Well, I know D, I know VF. That's 2 things. I need 3 things to find the 4th. For a candy, can anybody see what else I know? Can I use the 4.8 seconds over here, time? Is that how long it took me to come to a stop, or is that how long it took me to slide down the slide? That 4.8, is that how long it took me to come to a stop, or is that how long it took me to slide down the slide? Okay, so I can't use t. Someone work what? There it is, VF. What else? Psst. What?
VI?
What's VI?
Initial is 0?
No. I do know VI though.
2.5?
What?
2.5?
How fast was I going at the bottom of the slide?
2.5?
How fast was I going when I initially hit the ground?
2.5?
My final at the bottom of the slide, boom, becomes my initial over here. That's why this is a tough question. Nice. I owe you a candy. I'll get it in a second. Okay, I'm looking for an equation that's got a D, a VF, a VI, and an A in it. Dean, which one?
One and a half.
Pardon me?
One and a half.
One with a half?
Yeah.
I don't think so, because that's got a T in it, and I don't know T.
VF squared.
The squared one. VF squared equals VI squared plus 2AD. See it?
Yeah.
Get the A by itself. I'll give you a hint. A equals.
Divided.
More specific. Tell me what to write. What's going to drop down like a domino?
VF squared.
Write that first. So tell me, VF squared, keep going.
Minus VI squared.
Yes. Keep going.
Over D2 or 2D.
Let's write 2D. If you wrote D2, I wouldn't take marks off, but talking backwards, are you math speak, right? We usually go number then letter. Yep. Do you see that little aha moment that our VF at the bottom of the slide is our VI when we come to a stop? Okay. 0 squared minus 2.5 squared all over 2 times 0.2.
Do that one in your head, Mr. Newton.
Well, maybe. 2.25 squared is going to be 6.25 divided by... no, I'm getting yucky numbers now. I need a calculator. What's a little bit weird about your answer? When they hit the ground, did they speed up or slow down? So does the negative make me nervous or does it make me relax? I think it makes me relax that I probably did this right. Negative 15.6. Before we turn the page, how many of you have ever jumped off of a playground apparatus or off of a fence or off of a porch or off of a height and you accidentally land stiff-legged and you go, ooh, that hurt? Okay? Where is the D in this fraction? On the bigger you can make that, the smaller the acceleration that your body feels. And you'll learn in a few days what injures you in an accident is acceleration. So you figure out when you're about 4 years old or 5 years old, when you land, you bend your, what is that doing? Makes this number larger, makes the acceleration smaller, doesn't hurt when you land. So you figured out this equation intuitively as a 4-year-old, just by the feeling of it. Last one. You can use this in RCMP crash scene investigation. We'll finish with this. An RCMP officer is investigating a car crash. At the scene of an accident, there are skid marks that are 3.25 meters long. The driver of the car was speaking on a cell phone during the accident, and the cell phone records the sound of the skid for 1.2 seconds. Speed limit on the road was 60 kilometers per hour, and the driver claims he was not speeding. Should the driver be charged with speeding? What does this question want us to find? In physics, she said, how fast? In physics speak. Don't think acceleration is how fast. What's the final velocity of every car accident ever?
Yeah.
So I know VF, and we're going to fill that out in a second. So not final velocity. What does it want me to find?
Yeah.
Do you see how we reasoned our way there? Okay. We need to find VI. So let's do our VI equals question mark. Oh, what's the final velocity of every car accident ever? I will not tell you this. If we look at a car accident, if I give you a car accident question, you can safely assume VF is 0. What's that 1.2? How do you know? Yep. What's that 32.5? Now, you'll notice I'm not using that 60. I think what I'm going to do is I'm going to find VI, and if it's bigger than 60, write this person a ticket. If it's smaller than 60, no charges. Looking for an equation that has a VI, a VF, a T, and a D in it. There is one. The one with brackets? The second one? D, okay. D equals bracket VI plus VF times T over 2. Jaya, what are we trying to get by itself, Jaya? Where is it right now? Inside the? Oh, so times by 2, divide by T. And I get this. 2D over T equals VI plus VF. What was VF? So VI is going to be 2 times 32.5 all over 1.2. Get your calculators out. What do you get? So the speed limit was 60. Does this driver get charged? Oh, you hurt me. Verizon would love you right now. 54.2 what? What's the speed limit? 60 what? We better convert this. So 54.2 meters per second. How do I go from meters per second to kilometers per hour? Something to do with the 3.6. Oh, times? Are we charging this person? In fact, if they had injured some, by the way, I used my answer button. I didn't use 54.2, and I got exactly 195. If they had injured somebody, you could absolutely charge this person with vehicular manslaughter, and it would stand up in court. Totally would. Totally would. Yeah, this is do not pass, go directly to jail kind of stuff. Okay? But I can't believe all of you, oh, 54, smaller than 60. Compare units. Don't be working at Verizon. So that lesson took almost all class, and I knew it would, but I wanted to go at a pace that I thought most of you would find this okay. And can you see it really built on what we did last day? The 4 kinematics equations, but now with word problems. Tomorrow, I'm pressing pause. You're going to get most of class tomorrow to work on the homework. We're going to spend about 20 minutes going over the quest. What's your, hey, don't put, I haven't assigned the homework yet. Oh, I'm so tempted now to give you all of them because you all, number 1 is good. Okay. You can skip number 2. 3 is good. 4 is good. You can skip 5. 6 is good. 7 is good. Number 7, the RCMP question, just like the one we just did. So you can use the one we just did as an example, because 7 is tricky. Turn the page. 8 is good. 9, put a star next to. It's tricky, but see if you can figure it out. Nothing new there. It's just kind of an aha moment. You can skip 10. 11 is good. 12 is good. 13, 14. You can skip 15. Yeah, you can skip 16. 17 is good. You can skip 18, and we're going to put a star next to number 19. Number 19 is really tricky. Your hint for number 19 is there's technically 2 trips. The 2 that I put a star next to, that's my way of saying that's tougher than you'll see on a test. Probably tougher than you'll see even on a quiz, but maybe on a quiz is a nasty. And then if you're trying to get 100%, you can try the challenge question, but I'll leave that for now.